Today's the 23rd of August. We're doing triangle similarity. I want to know what information about the sides and angles of two triangles plus two triangles are similar. This is going to be fun. We're trying to prove certain triangles are similar by using AA, side, 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 and side angle side. Know that AA does not stand for what you think it might stand for. So don't worry. Okay? You don't get it, which is good. I'm glad nobody gets that. DJ. Yeah. It does not mean Alcoholics Anonymous. It means angle similarity theorem. You're going to need to write down this thing right here that says angle similarity. You also need to write down the postulate. Okay. So this is a very general statement. We have several ways to prove that certain triangles are similar. We're going to use in this class postulates. And what we're going to do, what we're setting up is what's called similarity proofs. Thank you. Just love. So I'm just going to go all the way through this, and we're going to talk about three main postulates or theorems today. So we're going to add to that throughout this course. The fun really begins now. Okay. Here's the first one: the angle similarity postulate. Okay. If two angles of one triangle are congruent, the two angles of another triangle, then the triangle are similar. Right? If two triangles of one triangle are congruent, the two triangles of another triangle, then the triangles are singular. Two angles, yes. Yes, that's exactly what I mean. Yes, ma'am. That's all. I think it's fun. Okay. All right. There is one thing that I did not put on today's lesson, and I probably should have told you this a long time ago. So this is what you need to add to your notes. This has to be in your notes. Okay. It's called the triangle sum theorem. Okay. Triangle sum theorem. Here is the triangle sum theorem. All angles of a triangle have a sum of 180 degrees. The most important number you'll learn this year, 180. All angles of a triangle have a sum 180 degrees. You have joined very, very big club. A very big club. The people that don't like geometry club.
I mean, I like to be on the thing.
And you'll like this.
Oh, and like you said.
Oh, it's plenty of fun. This is the nitty-gritty stuff. the nitty gritty, like the bare bone, like we're still in the basics of this. We're like really hammering. Imagine yourself as like a doctor right now. You think that doctoring is all about what? Saving lives. You know. No. This is the parts where you're like in med school and you're learning the bones, the muscles, and everything else in the whole body. You think that's really fun for doctors to do?
Yes. It'd be funner than this.
Probably would be. Yeah, because then I get more money. Not necessarily. Not if you're a bad doctor, you don't have a bonus. All right, here we go. Explain to me. No, you don't have to. Just read it. Explain why the triangles are similar and write a similarity statement. Oh dear. Since AC is parallel, parallel to DC. Angle B is congruent to angle E by the alternate interior angles theorem. We haven't done transpose yet, so that's coming. Once we do that, that'll make one sense. Angle A is congruent to angle B by the right angle congruence theorem. Therefore, triangle ABC is similar to triangle DEC by angle-angle similarity postulate. This is what we'll be doing. Okay. This is what we'll be doing. It's really not. These are called logic statements. For some of you, they will come naturally. For others, okay. Right, but all we're doing is we're going to put together all the information we know about this particular triangle, and we are going to come up with what we call proofs. We're building up to what we call similarity proofs. Okay. So let's do another example here. Okay. It says, explain why the triangles are similar and write a similarity statement. Okay, now check it out. I have to know a little bit about that other theorem that I just gave you guys, the triangle sum theorem, in order to solve this problem. Okay? The angles of a triangle have a sum of what? 180 degrees. So angle A plus angle B plus angle C will always equal 180 from any triangle. Okay. How much is angle A here? 43 degrees. How much is angle B? 90 degrees. It's got the right angle box, right? How much is angle C? No, we don't know what angle C is. That's the problem. Okay? That's 43 and 90. 133. If I solve for x, okay, subtract 133. No, it's not. Right? C is 47 degrees. 180 minus 133. So now all of a sudden, this helps me out a lot, doesn't it? It does. Okay. What is that first angle-angle postulate that we said? What is the angle-angle postulate? If two, let me read it back. You guys wrote it down. This is why you write these things down.
Two angles are similar. That means
If two angles in two different triangles are similar, that are congruent, then the triangles are similar. Okay. In this example, do I now have two angles in two different triangles that are congruent to each other? Yes, I do. Okay. Therefore, I can conclude that these two triangles are similar by the angle-angle similarity postulate. Okay. It says the triangle sum theorem gives you that the measure of angle C is 47. That's the dirt word. Okay. Angle C is congruent to angle F. That's the common sense of the logic that we talked about, right? Once this one equals 47, it's now congruent to that angle, correct? See the logical leap there, right? I mean, seriously, this is what we do right now. This week is what we're concentrating on. I know that E and B are congruent to each other because I know what the right angle box means. Okay. Therefore, our two triangles are similar. Of course, we have a few more that you need to write down. Okay. The side similarity postulate. If the three sides of one triangle are proportional. So the three corresponding sides of another triangle, then the triangles are similar. And then the side similarity postulate. The two sides of one triangle are proportional to two sides of another triangle, and their included angles are congruent, and the triangles are similar. See how this is going to be fun now. Okay. Now it's like a puzzle. Okay, guys? The bond is just bring the angles onto each right out. Yes, sir. I'm sort of about what? Okay. I know so very good. For similarity. Okay. That's not true. And that's why I'm putting it down. As long as those sides are proportional, okay? As long as those sides are proportional, angles will be congruent. Right? And what that's going to take, I know it's frustrating you, but what that's going to take is us getting through 4 units to develop that question. All right? So I'm gonna hit on that question throughout this unit. Right? What Ethan was saying was this, if I may. If these sides are, let me see if I'm saying this right. If the sides are proportional, then the angles should be proportional too, not necessarily congruent. I'm kind of pushing your words a little bit. I'm thinking I'm diving right into it, okay? And that's just not a geometric principle. That's what makes geometry tough. Is that actually it's the exact opposite. These angles here would be congruent. The angle measurements would be congruent. The sides would be proportional. Okay? And it has to do with the difference, really what it has to do with is trigonometric ratios, which is what we get to.
right angles. So that's going to be the easiest way for us to learn it, but it's true among things that are not just right angles. Okay. Down here in our side angle side similarity theorem, it says an included angle being congruent. Okay? That word included means between. Angle between the proportional sides. In this scenario, the angle between AB and CB. What is that angle? Okay, ask it again. The angle that is created by AB and CB. What is that angle? What? Think about this. This goes back to the very first day when I talked about it would be angle B. I said angle is created, a line segment, or a ray intersects another line segment, or ray. In this case, line segment AB intersecting with line segment CB, and they form angle B. That is what we call the included angle between two sides of the triangle. Okay? An excluded angle would be either of these two angles, A or C. They're not created here. They're not between those two sides. Okay. Now let's move on. Okay. I'll come back to it. I'll come back to it. I'll come back to it. Okay. All right. Check the work here. We're trying to verify that these triangles are similar. It says that triangle PQR, and STU are similar triangles. This goes right back to what we did last week, right? Okay. I got it set up. First, I got to determine if there's a similarity ratio between these sides. I take PQ over ST. Okay. Distance from P to Q, which is 3, over the distance from S to T, which is 4.5, right? I can plug, I don't care if you want to plug that into your calculator, you put it in fraction form, you put it in decimal form, whatever y'all want to do, okay? Right? It ends up simplifying to 2/3. Then I'm going to take Q to R and put it over T to U. QR, TU, same thing. 3 over 4.5. I'll simplify to 2/3. Finally, I'm going to take the last side, P to R, and put it over S to U. Hot dog, that's 2/3. Okay? All three of my sides are proportional. Using the side similarity postulate, I can conclude that the two triangles are similar. Okay? Yes, sir. Okay. Okay, so this is where we got to make sure we're clear right now. Okay, let me show you. Okay, I'm gonna create a new problem up here. Let's say that instead of having QR and TU, right? All of a sudden, I do not know what that length is. Okay? Guys, here's a dead giveaway. DJ, get off your phone, look up here, please. All right? Here's a dead giveaway. If I've only got 2 side lengths of the triangles, can I use side, side, side? No. Okay? Remember that logic stuff we're talking about? Logically, if I only have 2 of the 3 sides, I'm not going to be able to use side, side, side. I've got to have all 3 of the sides to be able to have side, side, side. All right, to get to your question. To prove through side angle side that these 2 triangles are similar, the only angle that I can use, angle P and angle S. Okay? Because they are included between the 2 given sides. Does that make sense? So, who was in here earlier today when who was in here? Jason, not nice. Okay, y'all ready for this? Angle R right there. What do we call angle R? Sorry. Is this an angle or is this a side? R to P. Is that an angle or is it a side? P to Q. Is that an angle or is it a side? All right. So there are certain things that will not prove similarity. This is one of them. Okay. Right. That's why, as the principle we'll talk about. Okay. You'll fall into that trap. Understand, what if I changed it to give me this angle, side, side? See the trap? Okay. It's a great question. That's my teaching point. That's part of my teaching point. We'll come back to that, just like I talked about later. We'll come back to that over and over again. That mistake will happen, okay? Just remember, okay? I guess this is my joke. Okay? Just remember, this can get you a lot of things in life. It can get you a lot of trouble in life. It cannot get you similarity, and it cannot get you congruence. Hear me? Okay? Give this away, you can chase this, whatever you want to do, all right? You can build it up, tear it down, and sit on it. But do not use it for similarity or congruence. Understood? That's why we're going to put a big old extra, okay? Not up in here. All right, so let's go back to a good example. If I had, here we go. John, what if I told you this? What if I told you that this angle is 40 degrees, this angle is 40 degrees. Now, do I have similarity between these triangles? 40 for angle S, 40 for P. Yeah, right? My sides are proportional. Okay, y'all see that? My sides are proportional. The included angles are congruent. That would change this to side, angle, side. Right? Before Josie falls asleep again, I want to make sure we get a couple of these written down, and then I will be done for today. Okay? It's okay. Reflexive property, symmetric property, transitive property of similarity. You need to write down these 3. The only thing you really need to write down, yeah, you know what? You need. I'll circle what you need to write down. You need to write down this. Okay. You need to write down this, and you need to write down. Right. All right. Let's do these. Let me explain them real quickly. I'll draw diagrams up here. Okay, here is the reflexive property in a nutshell. blue triangle ABC. Yeah. The blue triangle ABC is similar to the red triangle ABC with the reflexive property. Okay, anything that's mapped onto itself, right? Now we talked about that last unit. Transformation, right? We talked about mapping an image onto itself by transformation. Okay, here it's similarity. Okay, those triangles are similar. Right? The symmetric property is very, very similar to what I just wrote. Okay. Here you go. I've got triangle ABC in blue. Now I have triangle DEF in red. Right? ABC is similar to DEF. DEF is similar to ABC. Okay? What if I move the letters down here? What if it didn't map on there? And I told you, hey, guys, ABC through angle is similar to triangle DEF. That means that the other side of that is that DEF is similar to ABC. Okay? You see the logic coming out of this, right? Right? Guys, the same thing, look, this is the exact same thing as what you learned in like 4th grade. You'd always ask your teacher, does it matter if the X is on the left side or the right side or the equal side? Okay? You proved it out, right? Probably in elementary school they put it all the time. Did they tell you that? Yes. And they're dead freaking wrong. Because this property, all right, there's an algebraic property that goes with this that says if 5 equals X, guess what X equals? 5, all right? Doesn't matter which way that we write it, it's the same, okay? You got me? This is the geometric cousin, right? Our last one is the transitive property. So check this out. Here's the transitive property. I've got my 2 triangles, A, B, and C, D, E, and F. Now I create a new one. X, Y, and Z. Guess what this means? This means since ABC is similar to DEF and DEF is similar to XYZ, XYZ is similar to ABC. Okay? See the circle there, right? Got me? That's the transitive property. The key thing in the transitive property, keep in mind, probably going to come into 3. Got me? Probably going to come into 3. If A is congruent to D and D is congruent to X, X is congruent to A, right? It's like the double man, okay? So they're double 3. Okay. I think I'm gonna stop right there. Add one more, maybe 2. We're gonna get into proofs and stuff tomorrow. So see how we do that. Okay. Let me cut the recording off and then we'll get going.